add to stream करना पड़ेगा क्या? I guess I have added to stream, I believe. I think देखो आ रहा है क्या अभी? Something got changed, but not. Yeah, I think you can hear me now. But still they cannot hear me. Sure? That's dual only. Dual पे ही है. Hi all of you, can you all hear me? Hi everyone, can you all hear me? Awesome. So we'll begin. How was today? I believe all of you are preparing good enough for your CAT examination. So day by day, you're coming closer to the examination front. November 29th is going to be your D-Day. November 29th, it's going to be a D-Day for the examination. So keep this thing, which is your examination date, 29th of November, as the climax show. Okay. Now, if you know this, then all what you need is the preset goals, your weekly goals, and your monthly milestone. That's it. Nothing else. All what we need is a regular timeline which you have to follow. Give your mock. So I believe in the last session we have spoken about the mocks, and I had asked all of you to give a mock and then come for the session, the upcoming session. So how many of you have written or a mock or have seen 2019 or 18 paper? How many of you have given this mock? Any mock, mock number 1, 2, 3, 4, any mock. I'm not here to judge you on the level of marks. That's okay. All what I need is simple one thing. How many of you have given a mock? How many of you have seen the climax? Is there anyone who has given a mock so far? If no, just say no. If yes, just tell me yes. I just want to see how many of us who are live with us now have given a mock. So answer for the question, Shubham Rathod, yes, we will be dealing with the basic concepts. So the ideology is, I'll keep it simple. The objective for the sessions that we are keeping now is in the webinar sessions, which will be coming on a daily basis, we'll have the understanding of concepts and fundamentals. Two things. The concepts and fundamentals will be taught to you here. When you come for the regular live session, we will teach you the application-based questions and yes, the CAT and the non-CAT examination questions also. Okay, a lot of you have not given a mock so far. That's not a good sign. So one thing which I want to tell all of you is before my next session, which is next Monday, I want you to take one mock. That's it. Take one mock, irrespective of whether you have joined late or you have just started preparation. I don't care. All what I need you to give one single mock so that you see the climax. Okay, dude, this is the level where I have to be. You do not have to get demotivated by giving a mock. It's okay. That's the benchmark where we have to reach. Slowly, within time, we will be able to reach to that stage. But unless जब तक तुम वो देखोगे ही नहीं कि क्या आने वाला एग्जाम में तो समझ में कैसे आएगा, right? That's not going to work out. So the only thing which I want before the next Monday, I give you 7 days of time. Okay, I repeat, I'm giving you 7 days of time. In this next 7 days, I want you to give one mock. That's it. All right, then let's begin with the session. The agenda for today's session is something which we all have been, let's say, we have been taught when we were in school. The questions on time, speed, and distance. Okay, one relationship which I'm sure all of you would agree, you know, that is your distance is nothing but speed into time. Okay, for example, if you move at a speed of 10 km per hour, And if you go for 10 hours, then the overall distance which you cover is nothing but 100 kilometer, right? So this is one of the classic example of standard 9, 10, 10 questions which we have seen. Today's session will see all the CAT and the ZAT level questions. But this is my assurance. This is my, it's not an obligation on me, but I will ensure all the difficult ZAT and CAT level questions. I'll give you the easiest approach to solve these questions. So I want all of you to be live till the end of the session. We'll learn the concepts, but we'll see how do you apply those concepts to the CAT and the ZAT level questions also. Okay, so we'll begin. One thing which I want to highlight is a lot of people actually study by using formulas and theorems which are involved in time space distance, and the relationship of proportionality, where we know speed into time if it is distance, then we know speed is directly proportional with distance if time is constant. Similarly, time is directly proportional to distance if speed is constant, and vice versa. If distance is constant, then you will say speed is inversely proportional with time, and time is inversely proportional with speed. All of us have seen this kind of an approach when we were in our school. The objective is we are grown up now. So the objective for today's session is simple. We'll learn the application side. I'll teach you the application side because all these things have been covered in school when you were there in school. And one thing is which I want to highlight for today's session. We'll keep it very generic. When I say generic, it means we will just see the application without considering what is time, what is speed, and what is distance for today's session. Okay. All of us would agree that if I have to replace with something with S, T, and D, we know S into T is equal to D. We know speed into time is equal to distance. And if I have to replace this with a generic formula, you will say this is nothing but A into B is equal to N, which means all of you who are live, all what I want to say is the product of two values is the third value. I repeat, the product of two values is the third value. For example, A into B is equal to C, or N in the given case, can be replaced with speed into time is equal to distance. I do not want you to focus here. I repeat, I do not want any of you to focus here, which is speed into time is equal to distance. All what I want you to focus on is A into B is equal to N. All what I want is you to focus on this part. If you are familiar with A into B is equal to C, if you know the properties of these values, you can solve all the difficult questions also of the CAT examination. So let's spend some time on understanding what is A, B, and C. What we are doing, we are looking at the common functionality of A into B is equal to C, which is product of two values is nothing but the third value. Product of two values is nothing but the third value. For example, imagine if I give you 5 into 4. If A is 5, B is 4, C will be equal to how much? 20. C will be equal to how much? 20. Okay, now if I say, uh, the value of A got doubled. I repeat, the value of A got doubled, it becomes 10. So if the value of A is impacted, if it is becoming 2x, what will be the change in the value of C? You will say C will also become 2x because this time 10 into 4 will become 40 and this relationship is 2x. So you will say the change in A is directly proportional with the change of C. I repeat, the change of A is directly proportional with the change of C. If there's X percentage change in A, C will also change by same X percentage. For example, if I say out of speed, time, and distance, if speed goes up by 10 percentage, you will say that distance covered will also go up by 10 percentage, provided my time was constant. Provided my time was constant. This is not a function of STD. This is a function of A into B into C. This is a function of A into B into C. Similarly, if 4 into 5 is equal to 20, if 4 into 5 is 20, if I say this is A, this is B, and this is C. If I say A goes up by 25 percentage, I repeat, if A goes up by 25 percentage, what is the impact on C? If A increases by 25 percentage, 4 will become 5. This time 5 into 5 will become 25. 5 into 5 will become 25. If A goes up by 25 percentage, the increment in C is 5 upon 20, which is again 1 by 4, which is 25 percentage. That's what they want to highlight is speed is directly proportional with distance, time is directly proportional with distance. If whatever the change is happening here, the same will be the impact of change. The same will be the impact of change on D. provided here time was constant and provided here speed was constant. I hope all of you are familiar with these kind of simple values. I hope all of you are familiar with these kind of simpler values and the application. What we were looking forward was the direct proportionality application and the inverse proportionality application. I repeat, what we are trying to learn in today's session is we are looking for direct proportionality application and the inverse proportionality application. What I'm going to do now is changing the approach of direct proportionality to inverse proportionality. Imagine if A into B is equal to C. Imagine if A into B is equal to C, if 5 into 4 is equal to 20. If 4 into 5 is 20, the value of A is 4, the value of B is 5, and the value of C is 20. The question is, if A becomes, now we are looking at the relationship between A and C. Relationship of A and C when B was constant. Okay. This time you will see the relationship is inverse proportionality. If A is increasing, C will decrease. Similarly, if A is decreasing, C will increase. In a very simple mathematical formula, if I have to tell you, we know A into B is equal to C, 4 into 5 is 20. If I tell you that 4 is becoming 5, all of you, if 4 is becoming 5, the overall product is to be constant, that is 20. What do you think the value of B would be? What is the value of B? Just tell me. Comment into the chat box. What do you think the value of B would be? All of you will agree that the value of B this time will be 4. The value of B will become 4. So you said 4 into 5 is 20. 5 into 4 is also 20. We are looking at the inverse proportionality relation, which is A is inversely proportional with C. If I look at the value, this is A, this is B, this is C. All what we are doing as of now is we are keeping the value of C as constant. All what we are doing now is keeping the value of C as constant. So tell me, if A 4 is becoming 5, if B, okay, if 4 is becoming 5, I'm sorry, this is okay. If 4 is becoming 5, so the value of A is actually increasing by 1 by 4. The value of A is actually increasing by 1 by 4. If A increases by 1 by 4, let's see the impact of B. B was initially 5, it is becoming 4. So the impact is 1 upon 5. If C has to be constant. So we are checking for the relationship between A into B is equal to C. We found when A goes up by 1 by 4, B has to go down by 1 by 5 if C has to be constant. Right? We are looking for inverse proportionality. This time the relationship is between A is inversely proportional with B, provided my value of C is constant. Provided my value of C is constant. If I have to replace this in a generic form, I repeat, if I have to replace this in a generic form, you will say, if the value of A is going up by 1 by A, if the value of A is going up by 1 by A, the value of B will go down by 1 by A plus 1. Is this relationship clearly understood to you? See, 4 is becoming 5, so 5 is becoming 4. Okay. The impact is this value is going down. So I have a negative sign, the downward sign, which I have made for the value of B, which I have made for the value of B. Okay. Similarly, if it is the other way around, A into B is equal to C. Okay. And if 5 into 4 is equal to 20, if this time 5 is becoming 4, the overall value has to be 20. So what is this value? Please comment. All of you will agree. This time this value B will be 5. This time A is becoming 5 to 4. So A is the reducing. The reduction in A is 1 upon 5. The value of B is increasing. So 4 is becoming 5. So it is increasing by 1 by 4. So B is going up by 1 by 4. You will say this time if A is going down by 1 by A, I repeat, if A is going down by 1 by A, B will go up by 1 by A minus 1. This is the relationship which is important for you to understand. I repeat, this is the relationship which is important for you to understand in inverse proportionality. Because the kind of question which is going to be coming in the examination, mostly for the CAT and the other examination, you will deal with inverse proportionality, the relationship between A and B. I repeat, what I do is A is going up. If A goes up by 1 by X, B will go down by 1 upon x plus 1. All of you can take a note of this. Other way around, if a is going down by 1 by x, b will go up by 1 by x minus 1. This is a simple relationship of inverse proportionality. We will see the implementation of this in the actual time, speed, and distance. In time, speed, and distance, all of you will say speed into time is equal to distance. We will say speed into time is equal to distance. Now, which are two things will be inversely proportional? Speed and time. Which are two things will be inversely proportional? Speed is inversely proportional with time. Here, you will say if speed is inversely proportional with time, if speed goes up by 1 by x, if speed goes up by 1 by x, time will go down by 1 upon x plus 1. If speed goes up by 1 by x, time will go down by 1 by x plus 1. Similarly, if speed goes down by 1 by x, your time will go up by 1 upon x minus 1. This is a simple relationship which I want to tell you. All of you have to write down. All of you, I repeat, all of you have to like this. Okay. If you have understood this, please give me a thumbs up that yes, I have understood this, because now we'll be taking up the CAT level questions based on the simple understanding. One more request: if you are able to understand things, please hit the like button so that all the other fellow your classroom colleagues who have not joined us will get the intimation that the class is going on and they will come for the session regularly. So please hit the like button and we will take up the next question then. Just tell me, is this clearly understood to all of you? Is this clearly understood to all of you? Perfect. If you have done that, let's take up the questions now. Please hit the like button so that all the other fellow classroom colleagues who have not joined us will get the intimation that the class is going on and they will come for the session regularly. So please hit the like button and we will take up the question. Okay, now let's take up the question. Okay, we'll see. Raj, we'll take up in the actual question now. Let's try to do this question, which is one of the questions which I've given you now. The question is, traveling at 1/5 of the original speed. I repeat, traveling at 1/5/6 of the original speed. Manish takes 5 minutes. Manish is 5 minutes late in reaching his office from home. Find the original time he takes to travel from office to home. This is a simple question. We are looking forward for a relationship between speed and time. We are looking forward for the relationship between speed and time. All of us agree that speed and time is inversely proportional, right? Just by using the simple example that we have solved the previous set of questions, you will be able to solve this live. It says the original speed, whatever it was, if I assume it to be s, the new speed is actually 5/6 of s. Can we say the speed is reduced? Can we say the speed is reduced? Yes, the speed is reduced. Okay. Yes, the speed is reduced. If speed is reduced, you will say speed reduced by 1/6. So it says the speed has gone down by 1 by, yes, the speed has gone down by 1/6. So your time will actually go up. If the time is going up, time will be 1/6 minus 1, 1/5. It actually means time is up, which means time will be more. It says you will take 1/5 of the time more. We know 1/5 of the time which is being given to you is nothing but 5 minutes. 1/5 of the time which is being given to you is 5 minutes. So my original time will be nothing but 5 into 5, which is 25 minutes. A very simple application. A very simple application. This is not a CAT question, but in the upcoming slides, I've taken the CAT level questions also. If you have understood this application, give me a thumbs up. We'll take up the next question. Not at all a difficult question, which you can see. Perfect. This is Zat. Okay, the next question which I have given you is basically from Zat. Yes. In the order of priority, if you ask me what is a difficult exam, is it SAT or CAT? I'll say from my experience, whatever I've seen in the last 5 years, the quantitative aptitude section of SAT is slightly more difficult than what CAT question would be. Even if it is difficult, my only and only objective is if our concepts are clear. I repeat, if our concepts are clear, only and only one thing. If our concepts are clear, whichever exam you write, whichever exams you write, whether you write CAT, ZAT, IFT, or the other examination, you all can solve these questions very well. The only application that we have to deal with is speed is inversely proportional with time. If speed goes up by 1 by x, time will go down by 1 upon x plus 1. And if speed goes down by 1 by x, time will go up by 1 by x minus 1. A simple application, nothing more or less we'll see. Nothing more or less we will see. Okay, let's take up this question that we have. The question says, Rajesh walks to and fro. I repeat, Rajesh walks to and fro to the shopping mall. He spends 30 minutes in shopping. If he walks at a speed of 10 km per hour, he returns home by 7 p.m. If he walks at a speed of 15 km per hour, he comes home by 6:30 p.m. The question is, at what speed should he walk to return home by 6:15 p.m.? So the question is, he usually comes home by 7 p.m. If he increases his speed, he comes home by 6:30. So what further increment in speed should be so that he comes home by 6:15? We know your time is going to go less. आपको हर बार कम time लगने वाला है. So if the time is going less, obviously he has to pace up his speed. That's a simple formula or concept that you have to apply. I will not say it's a formula. That's a simple concept that we have to apply for the given context. But yes, if you read the question, certain date. Rajesh walks to and fro to a shopping mall. I don't care about this. He spends 30 minutes in shopping. I do not care about this. That's nonsense. The question actually starts from here. The question says, if he walks at 10 kmph, let's say if this is my speed and this is my time. If he walks at 10 kmph, he comes home by 7 p.m. If he walks at 15 kmph, he comes home by 6:30. You'll see one thing. If speed goes up by 1 by 2, I repeat, if speed goes up by, the speed is increasing by 50% here. The speed is increasing by 50%. So we are seeing this application, 50% ratio will be half. So the question is saying the speed, I repeat, the speed by which he is moving is improving by 1 by 2. So we know the time that he will take now will be reducing by 1 by 3. The time that he will be taking up now is 1/3 less of the time. And that's what we are checking. The time is reduced by 30 minutes. So this 1/3 of the reduced time, is 30 minutes. What is this 30 minutes? 7 to 6:30, it's 30 minutes. So the original time, I repeat, the original time will be nothing but 30 into 3, which is 90 minutes. The original time will be how much? 90 minutes. 90 minutes is equal to how many hours? 1.5 hours. What was the original speed that we considered? The original speed that we considered was 10 kmph. What is the total duration of hours that we found out that he had to move? Is 1.5 hours. If I multiply speed into time, what will come? The distance will come. 1.5 into 10 is nothing but 15 kilometers. This distance of 15 kilometers is never going to change. That's what the beauty would be. My distance is 15 kilometers. That will never change. That will never ever change. My question to you is, our standard time was 7 p.m. Okay, our standard time was 7 p.m. He reaches home by 7 p.m. The question says initially he takes 1.5 hours. Initially he takes 1.5 hours to reach home. Now instead of 7 p.m. he has to reach home by 6:15. Instead of 7 p.m. he has to reach home by 6:15 p.m. So the reduction is nothing but 45 minutes. The reduction is how much? 45 minutes. Instead of taking 1.5 hours, he has to reach by 6:15. So he has to take almost 45 minutes less. So you are saying now the time that he has is only 45 minutes. My overall distance. So I want the speed. The relationship between distance and time is distance upon time is speed. Distance upon time is speed. Do we know the distance? Yes, we know the distance. Distance is 15 kilometers per hour. Do we know the reduced time? Yes, we know the reduced time. that we have to cover this distance only in 45 minutes. Only in 45 minutes. 15 kilometer. If I replace 45 in terms of hour, you will say this is nothing but 15 divided by 3 by 4 of an hour. So 15 into 4 divided by 3, you will see the answer will be 20. And the answer is 20. Answer for the given question is 20. Is this clear to all of you? Sanat, the question that you have given me is how to find 1.5 hour. How to find 1.5 hour? Okay. It is being told. One thing has been told to you is the question says the speed is increasing by 50%. The speed is increasing by 50%, 1 by 2. So time will be more. More the time is 1/3 of the hour. 1/3 more will be required. 1/3, 1/3 is reduced. My bad. 1/3 is reduced. So you will see initially he's reaching at 7 p.m. Now he's reaching at 6:30. So he's saving 30 minutes. That's what the reduction of time would be. So 1/3 of the time, 1/3 of the time is 30 minutes. So my actual time will be 30 into 3, which is 90 minutes. This 90 minutes is 1.5 hour. This 90 minutes is 1.5 hour. If this is 1.5 hour, we know the total duration is 1.5 hour. Initial speed was 10. So 10 into 1.5 is 15 kilometers. So we got this part as a constant. So let me do it once again. For all of you, I'm doing this once again for you. But I want you to pay utmost attention. The question says, you come at 10 km per hour speed, you reach home by 7 p.m. You move at 15 km per hour, you come at 6:30. You move at what speed? You will come at 6:15. You will come at 6:15. This is what the question is. Okay. Now here, the initial speed and time relationship. If you see, if speed is increasing, time is reducing, right? So speed is becoming 10 to 15. Speed is increasing by 50%. So speed is going up by 50%, 1 by 2. So surely time will go down by 1 by 2 plus 1, which is 1/3. Going down means time will be reduced. My reduced time is 1/3. If so, 1/3 is reduced. 1/3 of the reduced time is the gap between 7 and 6:30, which is 30 minutes. So 1/3 of the time is 30 minutes. So the overall time will be 30 into 3, which is 90 minutes. This 90 minutes is 1.5 hour. My original speed was 10. We know speed into time is equal to distance. Speed into time is distance. So 1.5 into 10 will become 15 kilometer. This is my time. This is my total distance. Now we have relationship is between the equation number 1 and equation number 3. So it's now you move at 10 km per hour, you reach at 7 p.m. What speed do you have to come to if you want to come at 6:15? If you want to come at 6:15. बहुत सिंपल रिलेशनशिप है. आप ऐसे दिखाता हूं मैं. आप बताओ आपको ओरिजिनल टाइम कितना लगता है? Initially you will take 1.5 hour, right? But now instead of reaching 7 p.m. you have to reach at 6:15. Can you say now you have to reduce the speed by 45 minutes? You have to reduce the speed by 45 minutes. So instead of 1.5 hours, you have to move in 45 minutes. You have to move in 45 minutes. Can you say my time is half? Can you say I have to cover the same distance? I have to cover the same distance in half of the time. Can I say this? I have to cover the same distance of 15 kilometer in half of the time. Initially, I had 1.5 hours. Now I have to take 45 minutes less, so I have to reach in 45 minutes. Do you all agree now we have to take half of the time? If you have to take the same distance in half of the time, don't you think you have to double the speed? If you double the speed, 10 will become 20 in those. So my answer is 20. So my answer is 20. Simple questions. So you take you go as low as possible. Nothing to worry about. No one can touch you. If you have got this, please tell me yes, no, you got this. Then only I'll go ahead. All of you got this? So either a thumbs up or a yes or no, or even if you click the like button, I'll get to know that people are understanding what I'm teaching. Okay, next concept that we have got for you. The next concept that I have got for you is a concept of relative speed. Yes, sir. Yes, you can answer it. Still, you can use the same proportionality relationship for getting the answer. Yes, you all can do it. Okay. Next concept that I have for you is a concept of relative speed. This is something which is being taught to you in physics also. This is something which I'm not sure how many of you have solved this in math, but definitely one thing which you have seen in your real life also. We'll touch upon the CAT level questions of this uh, category of questions. This question that we have got for you is basically on, let's learn the concept first, and then we'll take up the question. The concept is relative speed, which means speed of A. I repeat, the speed of A. Whenever two bodies are moving, whether they are going in the same direction or they are going in the opposite direction, we are checking the speed of A in relation to B. We are checking the speed of B in relation to A. Okay. I hope all of you can recall something of your school day physics, class 9th and 8th and 10th, relative speed. If you have learned that, it's going to be easy for you to solve these questions. It is going to be easy for you to solve these questions. Okay. So how many of you have experienced, I repeat, how many of you have experienced when you are sitting in the railway coach, when you're sitting in the railway coach and if you're going in one direction, on the parallel track, there's also one more railway coach which is going parallelly to you. If it is going in the same direction, you will agree that you always felt that you are moving at a slower speed. You are moving at a slower speed than the original speed. Why? Because now you're not looking at your speed from the point of stationary, you're looking at your speed in relation to B. In relation to B, which means imagine if you are moving at a speed of 20 km per hour. If you are moving at a speed of 20 km per hour and there's a second railway coach parallel to you which is moving at a speed of 10 km per hour. Though your original speed, though your original speed is 20 km per hour, but you will say my speed in relation with the second coach is actually 20 minus 10, and you will feel that you're moving at 10 km per hour. You will feel you are moving at a speed of 10 km per hour. The reverse way, many of you must have felt when two railway coaches, I repeat, many of you must have felt when two railway coaches move in the opposite direction. So whichever seat you are sitting on, you will feel that you are moving at a much more faster speed. You will feel that you are moving at a much more faster speed than the actual speed of the train. So if you're moving at 20 kmph and the other train is moving at 10 kmph, you will feel that you are actually moving at a speed of 30 kmph because now you are checking your speed. Now you are comparing your speed with the other speed. So your individual speed of the train will get added if you're checking for the relative speed. Okay. So there are two kind of this. I'm sure that none of you will disagree that you have not learned this in school. All of you have learned this in school. The only objective is we have to see how does CAT level questions actually comes into picture when we see this kind of a question. But one thing is for sure, when you go in the same direction, when two bodies go in the same direction, if I have to check the relative speed is nothing but the difference of the speed. If one is going at 20, second is going at 10, the relative speed of A versus B is nothing but 10 km per hour. It's nothing but 10 km per hour. A school level concept that is being taught to you in the school also. And whenever you go in the opposite direction, I repeat, whenever you go in the opposite direction, you always feel that you usually are moving very faster, much faster than the other speed, than the other. So if two bodies are inversely are running against each other, A and B. So my relative speed A against B will look like A plus B. Will look like A plus B. Okay. No other concept of distance and time will be changed. Only speed will be replaced by relative speed. No other functionality will be changed. If I say my distance is nothing but speed into time, if we will say my distance is nothing but speed into time, we will still agree that yes, distance is this time will be nothing but relative speed into time. My time covered will be nothing but total distance divided by relative speed. All what you need to do is replace S by RS, nothing else. If this a simple concept has been understood, if this is a simple concept that has been understood by all of you, we'll take a couple of questions. We'll take a couple of questions. The first question originally, I'm sure that all of you will agree, this is not a CAT level question, but we'll see how do you solve these kind of questions, and then we'll take up the other questions also. The question says, let's read the question. The question says a thief escaped from a prison at a speed of 20 km per hour. After 2 hours, police followed the thief at a speed of 30 km per hour. When will the thief catch the? When will the police catch the thief? A question which has been on a simple concept of our school days will involve just three parameters: speed, time, and distance. Speed, time, and distance. The functionality will remain the same. Distance is nothing but speed into time, right? Okay, let's read. Take the question, and then you'll be able to understand faster. It says, let's say this is my playing ground. This is point number 0. Let's say this is my starting point where thief is coming. Let's say the theft happened at 7 p.m. Let's assume the theft. Let's say the thief entered the room at 7 p.m. The theft has happened, and now the thief is running in the direction. The thief is running in the direction which I have shown here. The thief is running in the direction with a speed of 20 km per hour. Okay, it is being told that the police got to know after 2 hours, which means from 7 to 9 p.m. Which means from 7 to 9 p.m. it is just the thief which is running. The thief is moving at 20 km per hour. If it moves for 2 hours, it's going to cover 40 km. It's going to cover 40 km. Let's say this distance is 40. Till this point, the police has not come into picture. Till this time, the police has not come into picture. The police came in at 9 p.m. I repeat, the police came at 9 p.m. Now it says the thief is moving at 20 km per hour. The police is going to move at 30 km per hour. At what time? Let's say at what time the police will be able to catch the thief? Surely police will be able to catch the thief because the speed of police is more than the speed of thief. The speed of police is moving more than the speed of the thief. The total distance that the police has to travel to come to a point where thief is as of now is 40. But since both of them is moving in the same direction, your speed will be converted to a relative speed. The thief is moving at 20 km per hour. The police is moving at 30 km per hour. So your relative speed in the same direction will be nothing but A minus B, which is 10 km per hour. So it's like police on a relative speed of 10 kmph. On a relative speed of 10 km per hour, police has to travel 40 km. So what time the police will take? 40 divided by 10, and the answer will be 4 hours. And the answer will be nothing but 4 hours. All of you got this? A very simple question, nothing to worry about. If you have understood this question, I'm going to take all the live CAT questions now with you guys. Just give me a thumbs up if you have understood this. Just give me a thumbs up if you have understood this. CAT 2004 question. Now I'm going to give you a CAT 2004 question based on the relative speed. Let me tell you all the CAT questions. Which comes be it on the advanced level or the previous questions of CAT. One thing is sure, they always give a story. They always give you a story. You got to decode the story. You have to form the basic math which is involved. You have to solve by using some basic understanding by solving this by to solve this question. Okay, let's take up a CAT 2004 question for you. Let me take up a CAT 2004 question for you. I love this question. I genuinely love this question because this will open all the doors of your brain or mind to think through before you solve the question. What usually happens the moment you see the question, let me say, the moment you see the question, the only thing that you will do, you will take the pen, you will take the paper, and you start jotting down the pointers which is being given to you. You start jotting down the pointers which is being given. That's not which is going to help you out. You need a simple common sense to solve these questions. Usually, if I solve this question which I have given you here, if I use a conventional approach, you will take roughly 5 minutes of your time. You will take roughly 5 minutes of your time to solve this question. However, if you use concept again and again, and let me emphasize only on this concept, if you use only concept, then you will take roughly 10 seconds to get the answer. You will take 10 seconds to get the answer. Okay. One thing which I want to tell all of you is we are repeatedly uploading all the CAT questions and the other non-CAT questions on YouTube channel. Please go through all the videos. Please go through all the videos that we have given on this channel. You can take up all these questions which is they are available on this channel on the doubt solving group also. Okay, we'll solve the questions for you, but please read or visit those questions once again. Let's take this question. The question says, two boats traveling at a speed of 5 and 10 km per hour head directly towards each other. They begin at a distance of 20 km from each other. How far apart they will be 1 minute before they collide? Oh my god, this time they are asking me a question. They are asking me a question which is the distance what they're covering in the last 1 minute. So if I have to form a diagram, imagine this is the diagram. This is my boat 1 and this is my boat 2. This is my boat 1 and this is my boat 2. Boat 1 is moving at 5 kmph and boat 2 is moving at 10 kmph. The question is they are moving in the opposite direction. So one thing is for sure they will collide. Surely one thing is for sure they will collide. If they are colliding, we have to find their distance. Let's say the original distance between both of them is 20 km per hour. Between both of them is 20 km per hour. And let's say in the last 1 minute, imagine, I'm just giving you a hypothetical case. If boat 1 reaches here and the boat 2 reaches here, and this is the distance of the last 1 minute. This is the distance of the last 1 minute. The question is, what is the distance between both of them in the last 1 minute before they collide? Okay. So practically, if you ask me, after how many hours will they collide? You will say, time is a functionality of distance upon speed, which is a relative speed. This distance is 20, and time is 10 plus 5, which is 15 kilometer per hour. They are moving the opposite direction. So it's 20 upon 15, which is 4 by 3 of an hour. Which is 4 by 3 of an hour. Okay. Which is 1 hour plus 1/3 of an hour more. 1/3 of an hour will be how much? 1/3 into 60, which is 20. So 60 plus 20, which is 80 minutes. The point is after 80 minutes, whenever they start, they will collide. They'll come here. So ideally what I have to do is distance covered in 79 minutes here, distance covered in 79 minutes by boat 1 and boat 2, and subtract the overall distance from 20. Boat 1 covered, boat 2 covered. Because 80 is the overall time, so I'm removing 79 minutes car distance. Then I'll be left with the last 1 minute, whatever the distance they will have to cover. But if I understand the common functionality, if I understand something which is way much more granular and simpler, you will say if this is boat 1 and if this is boat 2, boat 1 is moving at 5 kmph, boat 2 is moving at 10 kmph, the overall distance is 20 kmph, and the question for you is the distance between both of them 1 minute before they collide. So can I say this is the distance which they will cover in the last 1 minute? This is the distance which they will cover in the last 1 minute. Can you see the speed is constant? Can you see the speed is constant? If speed is constant, if I say, imagine in this way, imagine in this way, if I say in the first 1 minute, or let's say if your speed is 10 kmph, which means every 1 hour you're moving 10 kilometer. In the second hour, you will again move 10 kilometer. In the third hour, you will again move 10 kilometer. After 3 hours, you will cover 30 kilometer, right? This is a common understanding that we have got, which means my speed and my distance are directly proportional when my time is constant, which simply means आप खुद सोचो ना, अगर 10 मिनट लगता है घर जाने के लिए, the distance covered in the first 1 minute is same as the distance covered in the second minute, third minute, fourth minute, fifth, sixth, seventh, eighth, ninth, and tenth, right? So can I just say the distance covered in the last 1 minute? Can I just say the distance covered in the last 1 minute is as same as the distance which is covered by both of them in the first 1 minute when they move? Can I say this? All of you just say yes or no. I'm just saying the distance covered in the last 1 minute is as same as the distance covered in the first 1 minute. If you will say yes, the answer is over. You will just take 10 seconds to get the answer. You will just take 10 seconds to get the answer. The question says the speed of bolt 1 is 5 kmph. Speed of bolt 2 is 10 kmph. Both of them are going in the opposite direction, so the relative speed will be added up. So if I add both the speeds, can I say that is okay? So can you say in the first 1 hour, in the first 1 hour, in the first 1 hour, the bolt 1 covered 5 kilometer, and the second in the first 1 hour, bolt 2 covered 10 kilometer. So together, bolt 1 plus bolt 2 actually covered 15 kilometer. Can I say both one and two, both one and two, bolt 1 and bolt 2 together covered 15 kilometer in 1 hour. 1 hour is 60 minutes. Dude, if 15 kilometer is covered in 60 minutes, in 1 minute you are saying 15 upon 60 will be covered. 15 upon 60 is 1 by 4. So in the first 1 minute they are covering 1 by 4. So dude, in the last 1 minute also they will cover 1 by 4 only. No. Why the hell do I have to get into the ball game of covering the distance covered in 79 minutes and then we're moving from 20 kilometers? That's all bullshit and nonsense. No one does that. No one does that. It's a simple common understanding. Okay, so in the first 1 hour, 5 kilometer, in the first 1 hour, 10 kilometer, together 15 kilometer in 1 hour. 1 hour is 60 minutes. So 1 minute is 15 upon 60, which is 1 upon 4. That's it. If you have understood this, please like the video or give me a thumbs up or just say yes. So that's what. So as I said, all the questions which comes in CAT examination is a story. Time, speed, distance. To be very frank, if you ask me what is time, speed, and distance, time, speed, distance is also a story. It's a story which has been taken from a simple concept of A into B into C. A into B is equal to C. All of you know that what is A into B. All of you know how to multiply A into B to get C. If you know this, then surely you know time, speed into time is equal to distance covered. It is as same as 4 into 5 is 20. So 5 into 4 is 20. The change here and change here, the change here and the change here is the proportionality change which I have to consider. Is the only thing that I have to consider. Nothing above and beyond this. So generically, if I tell you what people do, people understand, okay, this is a topic which is being given to me. What all concept is available? What all questions are available? Can I solve the CAT level questions? Can I solve the NMAT level question? One thing is, before the topic, the concept is taken from the fundamental. The concept has been taken from fundamental. Let me tell you one thing. Your speed into time is distance has been taken from A into B is equal to C. Even your profit and loss concept of price into consumption is equal to expenditure has been absorbed from A into B is equal to C. So if you have to generally understand what is time, speed, and distance, you don't have to get into speed, time, and distance concept in the first go. all what you have to see is A to B to C. ये तो करने आता है ना. अगर इतना करके you can make manipulations of your own, take new numerical values, see the impact. So if I say is successive percentage change, do you think successive percentage change is also applicable in time field distance? In my previous webinar also I have taught you what is successive percentage change. So if A increases, C increases. If B increases, C increases. What happens if A increases, B increases? Definitely C will increase. But this is the application of successive percentage changes because both the values are increasing. Both the values are increasing. Speed into time is equal to distance. 10 km per hour, 10 hour is 100 km. If speed increases by 10%, time increases by 10%, distance will increase by 21%. Is the application which has been covered for you in the previous sessions. This is what math would be in. This is what simple concepts would be for you CAT examination. It is not difficult. So 10 will become 11, 10 will become 11, 11 is 121, and 121 upon 100 is 21% increment. So let me tell you, it is not a difficult concept. They are simple concepts, but they give you a story. All what I want you to focus on is come out of the story, see what is relevant, what is redundant, remove the redundant, use the concept and the application part. You can solve the questions in like seconds also. Okay, so that's what I had for this session which we had planned. If you have understood and like the session, please hit the like button once again. And do regularly come for the webinars and your classroom sessions both. We'll teach all the applications in the classroom sessions also. In the webinars, we'll take up a couple of CAT and the other non-CAT examination questions. So learn together. Learn as much as possible. Your sessions is going to be on a daily basis. Monday to Sunday, 8 to 9 p.m. You have to take these questions for the CAT examination. Perfect then. So I'll take a leave for today's session. And yes, if you have any question, what you can do, you can put into the comment box, or what you can do is just take up the questions in the doubt solving class. All right then. So thank you so very much for being with us.